Good morning, first period. How you doing?
Good.
Woo!
I hate school.
Aw, no. All right. So yesterday we talked about conditional statements, those if-then statements. Today we're going to kind of do more about the logic behind some of those and look at them and talk about different things. Had the light turned off. Hello, wake up. As it tries to figure out what to do with the whole lighting. There he goes. Good morning, little Elmo. All right, so the first thing we need to do is talk about whether statements are true or false. Okay? Seems fairly easy, yes? All right, is this statement true or false? Texas is in North America.
True.
It's true! We're happy. Yay. All right. Is this statement true or false? Athletes play football.
No.
Why isn't it true? Why is it
It's not
false?
true all the time.
It's not true all the time. Can you give me a counter example?
Yeah, baseball, soccer.
Awesome. Yeah. So athletes don't just have to play football, they can play all sorts of other sports too. Fantastic. All right, so you've got a really good sense of true, false. And notice right here, this was a counter example. Okay, so I'm going to scoot over so that we can add to the left. If that's a counterexample, what do you think the word counterexample means?
An example of the opposite.
Okay, tell me more. What do you mean by an example of the opposite?
Like the opposite. Like an example of the opposite.
The example of the thing that makes it false?
Yeah.
That's what you're trying to get at?
Yeah.
Yeah. You're exactly right. So counterexample is an example, one example that makes your statement false. So one example of the statement being false. Now, when we're talking about true, false stuff, wow, that's a really ugly handwriting. When we're talking about, zoom in there for you. When we're talking about these if-then true, false statements, all you need is one counterexample, and the entire thing falls apart. Okay? So when you're looking to prove things, you can't, hang on, what was I trying to say? When you're looking to prove things, if you can find one case that makes it false, the entire argument is false. Right? Okay.
As long as you have proof.
Yeah, as long as you got proof for it. We've got some qualifiers that can change the truth value of a sentence, and you see this a lot in multiple choice tests. Whoops. So this section will make you really good on true, false, multiple choice tests. Bless you, qualifiers. So qualifiers like some. Some athletes play football. Is that statement suddenly true?
Yes.
Yeah, because it's not all of them, only some of them.
Sometimes.
Sometimes.
Can.
All is another qualifier. All athletes play football. Totally not true. Because at one point I was an athlete and I did not play football.
No, I did.
None is another common qualifier that you see. No athletes, none of the athletes play football. Well, again, I mean, depends. Right? So these can, words like this, like what you had started to list earlier, all of those can change the truth value of a statement.
Usually more for investors. Can't.
Okay. Now we can add things, and you know how in a compound sentence you say cats are furry, dogs are furry? These are two different sentences, and you can mash them together with the word and. Cats are furry and dogs are furry, right? Or cats and dogs are furry. Okay? You can do things like that. You can do the same thing here with logic statements. With stuff like and. So we're going to go to an old nursery rhyme. Have you heard the nursery rhyme about Jack and Jill?
Yes.
Yeah, how does it go?
Jack and Jill.
Jack and Jill went up the hill
To fetch a pail of water.
Jack
Go ahead.
I don't know the rest. That's enough. Right?
Yeah, so we're going to look at just kind of the first line of that nursery rhyme. Jack and Jill went up the hill. So this is the one that we're gonna look at today. All right, this is an and statement, isn't it? Jack and Jill went up the hill. What are the two statements that are being said in this one sentence?
Jack and Jill.
Who goes up the hill?
Jack
Jack goes up the hill.
and Jill.
Jack went up the hill. We also have the statement, Jill went up the hill. Don't we? In that same sentence? So if we're breaking it apart, we should have those two sentences. Now the truth value of this comes into play here. If it's true that Jack went up the hill, and it's true that Jill went up the hill, is it true that Jack and Jill went up the hill?
Yes, ma'am.
Awesome. What if Jack goes up the hill, but it's false that Jill went up the hill?
Then Jack and Jill did not go up the hill.
Why not?
Because they didn't go up together.
Because they didn't go up together. Exactly right. So when you have this and statement in logic, both parts of it have to be true in order for the whole statement to be true. Okay? So take a moment, and I need you to jot that down. So we're going to talk about and statements. With and logic statements, both statements must be true. For the whole statement to be true. Yay. All right. So far, so good? Okay. Good. You guys are super smart. I'm not surprised at all. I knew you guys were smart. I knew it. Did you know it?
First grade. I didn't know it. I took a logic class in GCC for sure.
Oh, awesome. All right, so you're no longer allowed to talk in this section. Got to give everyone else a chance to figure it out.
I actually have done truth tables before.
Okay, awesome. So everyone, he's your new study buddy. Okay, when we do truth tables, you want to go and sit next to that guy. All right. What if we change the sentence? Okay? It's not Jack and Jill goes up the hill. It is now Jack or Jill went up the hill. Okay? We still have the same two sentences. Remember, I'm recording. I still have the same two sentences. I still have Jack went up the hill and I still have Jill went up the hill. Okay? But now, if Jack went up the hill is true, and Jill went up the hill is false, is it true that Jack or Jill went up the hill?
Yes.
Yes.
Why?
Because one of them did.
Huh?
Because Jack went up the hill.
Because one of them went up the hill. Jack did. Awesome. What if Jack doesn't go up the hill? That part's false, but Jill goes up the hill is true.
Jill.
Is it still true?
Yes.
Yes, because now one of them did. It's Jill. What if both of them go up the hill?
Then it's absolutely positively true.
It's absolutely positively true. I love all that modifier. It's awesome. So with or statements, with or logic statements, what happens if both statements are false?
Then the original statement is false.
Hang on, people are right. If both statements are false, what happens?
The original statement is false.
Yeah. Pretty much what Travis said.
What he said, he just totally reached in there and plucked it from your brain, right? Had nothing to do with that whole class, with his whole class. It was all your brain. Stop being Professor Xavier, man. It's all right. So with logic statements, only one statement needs to be true for the entire statement to be true. And this is for any and or statements. Bless you. And now we're going to go to what he talked about, truth table. Okay, you ready to set the table with me? All right, so I'm going to generalize it. So up here, we had Jack went up the hill and Jill went up the hill. With me so far? Right? I'm going to replace this statement, Jack went up the hill, with the letter P. Okay? So now that's any statement. P is representing any statement we want to say, from Jack went up the hill to cats are furry. Okay? And I'm going to replace the second statement, Jill went up the hill, with the letter Q. All right? So now Q can represent some other statement. Yeah, the sky is purple. Okay? With me so far? Okay. So here's what our truth table is going to look like. Truth table. I invite you to have a seat at my truth table. I'm so glad you got that. Here's a statement P. Here's a statement Q. Whatever those statements happen to be, I don't know, I don't care. Okay? Here's the value of P and Q. And over here we're going to have the value of P or Q. Okay? I'm going to zoom it in a bit more. There we go. All right. If P is Q, if P is true, P is Q. If P is true and Q is true, what's the value of P and Q?
True.
True. What's the value of P or Q?
True.
False.
They're both true. P is true, Q is true.
False.
The value of P or Q?
True.
True, because at least one of them is true.
Oh, okay.
All right. What if P is true, but Q is false?
Still true.
It's still true over here on the P or Q, yes?
Yes.
What's the value of P and Q?
False.
Beautiful. If P is false, but Q is true, what's the value of P and Q?
False.
False, because you have to have both. What about P or Q?
True.
True, because you only need one to be true. And here's the last one. What if both of those things are false?
It's false.
P and Q
False.
is false. P or Q
False.
is false because none of them were true.
Ma'am, I have a question on the top one.
All right?
For the P or Q,
Yeah,
or means one or the other, correct?
correct.
So if they're both true, shouldn't that be false with both of them, not one?
Great question. It is true because you had one of them being true. I don't care what happens to the other one. As soon as I get one of them true in an or statement, the whole thing is true, regardless of what we do with the other one. So if the other one's true also, great. We still got one of them true. Does that make sense? Okay. I see a little bit of nod. Yeah? Okay. It's kind of hard to tell. You're backlit by the window and it's dark. And I kind of see the pencil bobbing. All right, I want to trip out your brains. Are you ready?
Oh, I'm ready.
I want to trip out your brains. I want the truth value. That squiggly line means not. The squiggly line means not. Okay? I want the truth value of not P and Q. All right? So let's look at P. What's the truth value of P on this first line? True. So not P, the value of not P would be? Yeah, you're right. False. It's the opposite. So now P is false and Q is true.
So it's both false.
So it's false.
Wow.
Because I had one that was false. Not P and Q.
False.
Oh.
You see it?
Is it false?
It is false. You see it?
Ooh.
Smart.
Not P. Okay, if you're feeling it and you're like, you got it, and it feels easy, stop answering out loud. It's okay. Let someone else who hasn't gotten a chance and is wanting to speak up to just double check to make sure they're in the right spot. Not P. What's the value of not P on this one?
False.
False.
We have a disagreement. What do we have originally? What's here the value for P right now?
It's false.
False.
The value for P right now is false. Not P means you negate it. You make it the opposite. The opposite of false is
True.
true. So not P right here would be true because it's currently false. And now it's true. So not P, true. And Q, true. So its value is
True.
yes.
Okay, I get it now.
Because both of them ended up true.
Yeah.
Not P, the new value is true. And Q. So now you have a true and a false.
False.
That's an and. Is that full statement true or false?
False. Because you have one false statement.
Oh, yes. It's false.
I'm looking over here.
False.
Because I hear you. I'm not ignoring you because I'm looking over here. What do you all think?
False.
School game too strong.
Okay. Yes. Fantastic. Be prepared for a skill check on something that looks like this. Okay? All right. It is. Good morning, third period. How you doing? Good. Woo!
Very good.
Very good, very good. Okay, good, awesome. We're taking a page in notes today, Wednesday the 24th. The title, Logic of True and False. As you can see, all you need are writing instruments today, and you can tell that I have my usual 4 colors out. So if you want to copy those colors, that would be awesome. Again, you don't need to have those colors, but that's what I'm going to be using. All right, here we go. So So this is kind of branching off from the conditionals. We had the if-then kind of statements. But this time I want to take a moment and discuss what happens when we start being really hardline about things being true and things being false. Okay? So the first thing I want to do is just kind of start off with a quick example and ask, is this true or false? And the sentence is, geometry is a math course.
Mm-hmm.
True or false?
True.
True. All right. Seems pretty easy. Awesome. All right. This next one, true or false? Fish live in lakes and streams.
Mm-hmm. True.
True?
Yes, ma'am.
What about my sister's goldfish that she's had in a bowl for like 2 months and then it died?
That's also. They also live.
But it's still a fish, is it not?
Yes.
No, but you didn't say only.
True, but since it doesn't have any other information involved, we can't assume that it says or that it means that fish could also live in fish bowls or aquariums or oceans.
No, so you're asking for a
Wait, you
specific
say
thing for
all
lakes and
fish
streams.
Right, I did not say all fish. I just said that fish live in lakes and streams. But since I'm being very specific, I'm saying that fish really don't live anywhere but the places that have been mentioned. Because we can't use any outside information in determining the truth or false of this
So what you
sentence.
said doesn't matter.
How do you mean?
Like what you said about your goldfish.
Well, that would
We're not
be
talking about goldfish and we're not talking about bowls.
true, but I'm asking, is this statement by itself true or false?
It's true.
It would be false because these fishes can also live in different kinds of bodies of water.
But it
That's-
doesn't say only.
But that's
live
not
in.
only though. You put false, that's wrong. I give you my honest opinion.
No, and this is the point in this class where where we start going rounds and start having differences of opinions. And so the silence wasn't me like ignoring you, shutting down. It's me sitting there weighing it and going, "Well, I totally see where you're coming from on this one." And I'm trying to figure out how to make this example
Boom,
work the way I
blindsided.
wanted it to.
It's true.
And it's not working the way I wanted
Yeah,
it to.
'cause
Because you have very valid arguments.
If you would have said only,
your
it would be a
argument
different
is
story.
invalid. Fish only
And
live
so-
in lakes and ponds and
Okay.
well, lakes and streams, it would have been different.
All right, so then let's add that in there then.
Now, it's different.
All right. Yeah?
That was false.
No, that's false. Okay, cool. Thank you. It's false. So now give me a counterexample. I loved that. Thank you. Give me a counterexample.
A what?
A counterexample.
Austin plus school.
Pancakes are square.
For this statement, fish only live in lakes and streams. What's the counterexample?
Salt water?
Okay, saltwater fish would be a counterexample because saltwater fish live in saltwater. Beautiful. So the important thing here to take away from, whoopsie, there's my star. The important thing I had here was that word counterexample. And y'all gave me a counterexample, and so the question is, what does counterexample mean? You gave me one. You clearly know what this word means if you were able to give me a counterexample to the
When
statement.
you give an example that is contrary.
Yeah, well, he said he took it out of your mind, right? Psychic. It's okay. Psychic memo. That was the assist right there. You thought it, he said it. Perfect assist. So counterexample was an example
Batman.
that shows that your statement was
Can-
false.
can you- oh, it's just example. Oh, okay. Never mind.
It's okay. An example that shows,
I'm a phone.
A phone?
that's mine, that the statement is false.
Please, would you please put away there?
I will. I'll turn the ringer off. I'm sorry.
Your cellular device.
Consider
There we
this
go.
to know. Because if not,
Okay.
you would be asking me.
Someone's gone to the movie theaters recently.
Yeah.
Awesome. Okay. So that wasn't too bad at all, was it? And you notice how we had to add this little word only to make this one, because otherwise we were arguing about the truth value. Some were saying it's true. I was trying to argue it's false, and you said no, you have to have that word in there. And I loved that argument. And that word right there is called a qualifier. It qualifies the statement and helps nudge your truth value one way or another.
But what's the qualifier in this one?
In this one would be the word only, would be the qualifier this time. So the qualifier nudges the truth value so that it's one way or another, because otherwise some of these statements could go either way. And you have words like only, which is the one that you came up with. All.
Time.
What?
All the time.
All the time, yeah. Whoops.
Kind of like a universal statement thing.
Yeah, kind of like a universal statement. Either universally, like making it like singular, like just that one universally, or all of them in the whole universe, or none of them in the whole, yeah.
Only. All.
What did you say? All?
All the time.
All the time, thank you. I was trying to remember what you said. None. Okay? So words like that are qualifiers. Okay? Fantastic.
Miss,
Yes, ma'am.
do you have an extra water can buy from you?
No.
An extra what?
Water.
No, I'm sorry, hon. I don't. I really don't. Okay, so now take your writing utensil, big line under all of that, and we're going to go to the next kind of big statement.
Level.
Yeah, the next level. Do y'all know the nursery rhyme Jack and Jill?
Yeah, you know when I'm in here, that's a ton of water, nestle down, this ground,
That one, right? Nicely done. What? So the nursery rhyme goes, Jack and Jill go up a hill
I made some eggs.
and pick up some water. And Jack falls down and he busts his crown, the crown of his head. And Jill falls down after. She's trying to chase him and she falls. Okay, so they both fall down the hill. It's a very morbid.
It's common
Nursery
sense.
rhyme.
If you see somebody that fall.
Hey, you see somebody falling?
are.
Why would you want to fall to
The whole
the
thing is
Huh?
They all kinda are.
They all,
The
yeah.
statement? I mean,
All right,
basically,
so we're
don't
gonna
fall.
we're gonna look at just we'll look at just the first sentence of that particular nursery rhyme, which is Jack and Jill went up the hill. Okay, this is a compound sentence. We can break it into two very smaller, simple sentences. Jack went up the hill. Jill went up the hill.
No.
Okay, so I'm gonna write those sentences down. Jack went up the hill. I'm gonna zoom in a little bit more here. So Jack went up the hill and Jill went up the hill. But I'm writing them as separate sentences. All right. The nursery rhyme states Jack and Jill went up the hill. In order for that statement to be true,
and
what has to be true?
They both,
Say it louder one more time, right here.
if they both went up the hill.
That they both went up the hill.
And fail.
If they both went up the hill,
Fail.
then this statement, Jack and Jill went up the hill, is true. If I break into these two separate sentences and I say the sentence Jack went up the hill is false,
Miss, are we going into English or something?
and Jill went up the hill is true. So this one's false. Jack did not go up the hill. Jill did. This sentence is now
False.
false because they didn't both go up the hill. Fantastic. So over here on this left-hand side, I want you to write and. This is our big statement and. And the notes for this is with and logic statements. Logic compound statements. But that's weird. With and. Yeah, we'll leave it. Compound compound, I can't spell. Statements. This is a statement that has two or more statements stuck together, and you have an and in there. Both statements must be true. True. For the entire statement to be true. All right. Not bad. Listen. We're going to make this a what if comic. What if the nursery rhyme was not Jack and Jill go up the hill? What if it was Jack or Jill go up the hill?
That'd be weird.
Once it would be weird, but
Be a false and true statement.
how do you mean false and true statement?
Because you never know which one did.
Okay, great. So now I have to give you some more information. Fantastic. Okay, so Jack or Jill went up the hill, and I'm going to tell you that Jack went up the hill, but Jill didn't. Is the statement Jack or Jill went up the hill true
Yeah.
or false?
It's true.
Yes,
Why is it true?
because it
Because
says
one of them
or,
has
so
a 50-50 chance and did.
Because one of them did, and the statement says or. So I don't care what the other one does. As soon as I get one of them being true, the whole thing is true. Awesome. So, with or, logic compound statements. That's really oddly said, and I'm sorry. Only one statement needs to be true for the entire statement to be true. Excellent. Excellent.
Damn it.
Okay. We're going to play with truth tables next. Truth tables. Yeah, I'm inviting you to come and eat at my truth table. I'm so glad you took a second. All right, so we're going to make a little table here. So a truth table, yes please. A truth table is a way to very quickly glance at things in a symbolic way so that you don't have to sit there and try to figure out what this statement is talking about. And it prevents you from doing the, well, is this statement Jack goes up the hill, is this true or not? And getting stuck on thinking that without, preventing you from moving forward. So I'm going to replace the first statement, Jack went up the hill, with just a letter P. And that's going to represent any statement you want. Squirrels are furry. Right? I don't know. Just whatever. The statement doesn't even have to make sense, right? Okay. And then the second statement I'm going to replace with another letter. I'm going to use Q. And that can be some other statement. Again, doesn't have to make sense. The sky is green. All right? Okay? With me so far?
Are you colorblind?
All right. Now, we're going to look at the statement, the compound statement, P and Q. Okay? And I'm going to give you some truth values to these statements. If the statement, the first statement you made, represented by P, is true, and the statement made by Q is true, what's the truth value of the compound statement P and Q? This one, the truth value of P is true. The truth value of Q is true.
So P must be true.
P and Q must be true, yes, because both of them are true. At this point, I don't know what those statements are. I mean, it really could be something as silly as squirrels are furry, true, and the sky is green. True. Well, assuming the sky is green is true, then the phrase squirrels are furry and the sky is green has to be true if we're forcing the phrase the sky is green to be true. Okay? All right. Next one. P is true, Q is false. What's the value, the truth value of P and Q?
Put like a T and then put like an F.
You only can choose from true or false.
Okay, put a T and then just put like a little line.
False. Why is it false? Because the false undoes the true?
The true is first.
The true's first? How many on an and statement do you need in order for the whole thing to be true? Both of them. Here, there's only one that's true. So that means the entire statement is false.
So that goes the same for the rest.
So look at the next one. P is false, Q is true. P and Q is
False.
the last one. P is false, Q is false.
False.
P and Q is
False.
double false. All right, I'm going to try to trick you. We're going to do the OR. P is true, Q is true.
It's true.
P or Q is,
True.
Oh, you're using or now.
we're using OR. P is true, Q is false.
True.
P or Q is,
True.
how many do you need for it to be true?
One.
Oh no.
Just
it's
one.
true,
How
it's
many do you
true.
have?
One.
So then it's
True.
lovely. Thank you. P is false, Q is true.
True.
P or Q is? P is false, Q is false. P or Q is?
False.
Okay, I'm going to make it harder. Because clearly this is too easy. No. This little one squiggly line, the tilde, means not. Not P. The original truth value for P right here is true, so the opposite truth value is, what's the opposite of true?
False.
False. Okay, so all I'm going to do is I'm going to look at this column for P, and I'm making the truth values their opposite, not P. Okay. Not P or Q.
I don't get it.
Oh, I get
Not
it. I get
P.
it. I get it. I get it.
Or Q.
They're all gonna be false.
All right, look at P. The truth value for not P is false.
False.
The truth value for Q is true.
They're false.
So we have one false, one true. The entire OR statement is
False.
true.
What?
Because there's one who states.
Because there's
Oh,
one of
yeah.
them that's true. We did not say, notice how, okay, we'll do another example after this one. So you can see it. The next one. Not P is false. Q is false. Not P or Q is false. Not P is true. Q is true. Not P or Q is true. Last one. Not P is true. Q is false. Not P or Q is,
False.
Is this just based on the previous,
It's true.
column?
It's true.
yeah, just based on
Oh,
the
it's
not
false.
P
It's
column and the
false.
Q
It's
column.
True.
It's false.
Argue it out.
Answer.
Why is it false?
But it says or.
One true statement.
But it says or.
Not P is true. Not P or Q is. Wait, what?
Look at, okay, not P. So look at the not P column.
It's true.
Okay, look at the Q column.
False.
And the statement is or.
So it's true.
It's true.
Told you.
You only need one of them to be true for the whole or thing to be true.
So now we go back to the.
I don't get it.
You don't get it? Okay,
hurting
let,
my brain.
it's hurting your brain. Okay, let me try to do one more example.
A.
All right, I'm going to do it this way. Not P or Q.
Again?
But
No,
look
it's
at the
different.
difference. I changed it. I put parentheses. Okay? And did you hear the difference in how it was said? This one right here, this first one was not P or Q. This one is not P or Q.
Talking about both.
So it's talking about both here. So so look at the P or Q column
They're gonna be false because there's always a P.
and then
I know.
take the opposite.
Whoa, what would
Wait,
So start with the P or Q column right here. And then the not symbol says make them all the opposite. No thinking required.
what?
I don't get it.
The only one that I don't get is the last one.
Did you get it?
One false. Look at
Yeah.
Okay.
P or Q.
Wait,
The last one.
why'd you put true in the
Oh, I
Because
get it.
before
I got
that,
it.
there's-
Since it says P or Q, it says true, false.
I don't have any more copies. I'm waiting.
Yeah.
No.
I
I
don't
hope
get the
so.
second to the last one.
Okay? All right, I'm going to cut the video here. I'm going to cut the video here. Good morning, fourth period. How are you?
Good.
All right. Notes day, we are recording. We're going to be talking about the logic of true and false. There's how I would like you please to set up your notes paper. Here we go. As you can tell, I've got my 4 colors of pens. We're not doing any drawing, it's just writing today. You don't have to have the different colors, but you're going to see me change now and again. All right, so the first spot I want to talk about is to comment that we had looked at those conditional statements, those if you meet some condition, then something else will happen, right? This is now breaking it apart and discussing what happens when various things are true and false. Okay, the lights are going to go out, so I'm going to wait for a second for this thing to realize the light is off. Hello? There we go. All right, so let's start with this particular statement. The question for you is the statement true or false? Texas is in the United States of America. True or false?
True.
True. Right now, anyway. I don't know. True. We're part of the United States. Fantastic. Is this statement true or false? Birds fly.
True.
True or false?
True.
Okay.
All birds fly.
Oh, why not?
Penguins.
Is it a bird?
It has to be more specific.
Oh, no.
It should be more specific. If we're going to try to find a way to say true or false, you know.
Well, it can't be none of the both, because some fly and some don't.
Right. So this statement, as written, we have to say is false because it's not specific enough. And the counterexample you gave was penguins, because penguins don't fly. And so that's the first kind of big important thing that you guys already did naturally. Fantastic. Was to give a counterexample. The statement was birds fly, and you countered with penguins don't fly, and penguins are birds. The counterexample. So what's the definition of a counterexample?
False and example.
An example that makes it false? Perfect. It's exactly right. So a counterexample is an example that shows the statement is false. I'm going to zoom in real tight on that because I realize it's pale and hard to see. There you go. So a counterexample is an example that shows that the statement is false. This is that the lawyer shows, right, on TV, where they go around and they're making all these arguments and everything's great, and then the one lawyer, the defense lawyer, whatever, because the guy's really innocent, but all the stuff, all the evidence is showing that he's guilty and he's all sad or whatever. And that lawyer pulls out that one thing and says, but this one thing isn't true. And suddenly the rest of the case falls apart. Right? That's the counterexample. Right? Counterexample, really powerful. You only need one counterexample in order to prove an entire argument. Could be hours worth of work. You get one counterexample and suddenly the whole thing is just doesn't work. Okay? Awesome. Now, you had said something really powerful, that we had to be more specific. When in the statement, just birds fly, if we wanted to change this to a true statement, what would I need to rewrite it as?
Do some birds fly?
Make it a statement rather than a question.
Oh. Some birds.
All right. Some birds fly. Awesome. And the moment you add that word some, this truth value changes from false to true. And so this word right here, this word some, is acting as a qualifier. And a qualifier is a word that nudges, that changes the truth value. It either makes it completely true, it shoves it into the realm of false, or if we can't tell, like we're leaning one way or the other, it's going to push us into one or the other and make it very clear for us which one it needs to be. Okay? And these are words like some, which is the one you used. All is another qualifier. Most. None. And those are just a few. There's a whole bunch like this. Okay? Yes, sir.
How does this really prove like artificial intelligence?
I'm so glad that you asked. You know how I said earlier in the year you guys are suddenly attorneys? And I said you all passed the bar, you're all attorneys, now we're going to be arguing? You have to make sure that when you give me an argument, we're going to get into debates, and I'm going to want that, okay? It's going to make me super happy. That your arguments need to be logical, and you have to make sure to avoid me being able to find a counterexample to prove you wrong. Or prove each other wrong. So if you two were going at it and arguing, you're like, no, this is true, and you're putting all these evidence, you can find that one counterexample, you've completely shut her down, she has to start from scratch. Make sense? Okay? This connects into the algebra when you're like solving for x, right? And you're like, oh, well, x can be all of these numbers, and if you find one number in that whole group that makes it so the sentence, the number sentence, when you put it in, it doesn't give you the right number you're looking for, that would be a counterexample. And you're using the same sort of concept and same sort of thinking. Okay? All right. Start a new section. Okay? Start a new section. So put a line straight through, across one side of the paper to the other. Have y'all heard the nursery rhyme, Jack and Jill went up the hill?
The movie?
The nursery rhyme. Jack and Jill, say it with Jack and Jill went up the hill. Water. Jack fell down and broke his crown, and Jill came tumbling after. Okay? You've heard the nursery rhyme, most of you? Okay, I've got a few head shakes. That's okay. It's definitely an English language kind of, my mom never said it to me. I learned it in school when I went.
I heard the Humpty Dumpty one.
The Humpty Dumpty one? Yeah, Humpty Dumpty sat on a wall.
Yeah.
He fell down, yeah. All these nursery rhymes are really morbid. Basically, the whole premise of this nursery rhyme is you have these two people, Jack and Jill, and they walk up a hill to fill some water. And Jack falls down and he breaks his head open, and so Jill chases after him and she falls down too. That's the whole story.
So they both.
Well, at the very least, they're both hurt. No, I'm with you. My brain totally went, so they're dead. But at the very least, they're both hurt. Okay? That's what we can say for sure. I want to look at just the first sentence But I want to rewrite the first sentence, Jack and Jill went up the hill, as two different sentences because of that word and. I have the sentence, Jack went up the hill, and I have the sentence, Jill went up the hill. Okay? So I have those two sentences. The nursery rhyme starts, Jack and Jill went up the hill. What needs to be true about these two separate statements here on top? Jack went up the hill, Jill went up the hill. In order for the entire sentence, Jack and Jill went up the hill, to be true. In order for Jack and Jill went up the hill to be a true statement, what has to happen? They both have to go up the hill together. Hopefully. Maybe not necessarily at the same time, but they both have to do it before we call it done. Okay? That's, whoops. We're going to call this the and statements. With compound logic statements. So when you're making an argument and you're going to use the word and in your argument, both parts of the statements need to be true in order for the entire statement to be true. If even one part of that thing isn't true, the whole thing is false. So far, so good? If you're having trouble seeing in the back, you have my full permission to quietly get up, come closer, and you can go back to where you were sitting before. Okay. I'm going to take my pencil and I'm going to do a dash. I'm going to use a squiggly line. Because we're done with the and, but we're not done with this section. What if I changed the nursery rhyme? What if I changed it from Jack and Jill went up the hill to Jack or Jill went up the hill? In order for the phrase Jack or Jill went up the hill to be true, what has to happen? One of them has to go up the hill. Do I care which one?
Nope.
Do I care if both do?
Yeah.
Well, if both do, is it true?
Yeah.
Yeah, because one of them did. Both of them did, right? All right, so with, I'm going to add up here on the and part. I need to differentiate because otherwise these are going to look exactly the same. So on this top one, please add in the word and right here. I'm very sorry to do that. Because the or is going to look exactly the same, but I need to have the word or in there. Thank you for that, and my apologies. So on the or, with compound or logic statements, only one part of the statement needs to be true in order for the entire statement to be true. When you're done writing, put a big line from one side of the paper directly across to the other side of the paper and give me thumbs up. Thank you. 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 I heard the line, that pencil. Great sound. Thank you. All right. I'm going to scoot it down just a little bit. I will leave the or showing so that you can see it. Okay. We're going to do a truth table. You're all invited to come and eat at the truth table. Was it super lame? Yeah, thank you. No one even snickered. Thank you. All right, so what a truth table is it gives you a really quick way to reference what happens with different possibilities. Okay? Because in the example that we used, Jack went up the hill, Jill went up the hill. We don't know if Jill went up the hill or not. Right? Until we tell us. Right? We don't know if Jack went up the hill until we're told. And so a truth table will give us a really quick way to see that. But in order to make that happen, I need to use some symbols. Sorry. I'm going to replace whatever the first statement of our thing with the letter P. Okay? Now we can have P be representing any statement we want. Like, squirrels have feathers. And it doesn't have to make any sort of sense, okay? This statement. And you're sitting, your brain is sitting there going, no, that's false, miss. Doesn't matter, okay? It's just a statement. So I'm going to replace any statement, I'm going to represent any statement with the letter P. And I'm going to represent any other statement, something else that's different from the first one, with the letter Q. Now these statements have two choices. They can either be true or they can be false. And having a table like this allows me to compare things. Like the relationship, what happens when I try to say P and Q? Q, yeah, it's a Q. Sorry. Let's take a look. So I'm going to fill in some truth values. Okay? These are all the different cases, all the different possibilities that are available when you have P being true with some combination of Q being true. Yeah, fill this in right here, the true and the false. And if you happen to have red and green, that makes it really kind of visually quick to see. If you don't, that's all right. All right, so now let's look at the P column and the Q column. P is true, Q is true. That makes the statement P and Q be a true statement.
Yes.
Because in order for it to be true with an and, both of them have to be true. They're both true, so the whole statement is true. P is true, Q is false. P and Q is beautiful, because you need two of them, and I only have one. P is false, Q is true. P and Q is awesome. All right, if this is starting to get easy, please don't verbalize. Those of you who are still concerned, I'd like you to verbalize and take that risk, okay? All right. P is false, Q is false. P and Q is? I didn't hear you? You're taking a guess. All right. So for an and statement, how many do you have to have true in order for the whole thing to be true? Back up here.
One.
With an and, how many parts need to be true?
Oh.
Both. Okay. So down here, how many parts are true? None. Is that both? No, so it can't be true. It has to be false. All right, make sense? For most. All right, I see your face. Let's run the rest of the truth table, do a few more, see if it clicks, and if not, come up and see me and we'll do one-on-one, okay? All right, let's look at P or Q. Okay? P or Q.
You ready, Noah?
Yeah, just, we're going to keep adding. P is true, Q is true. P or Q is?
True.
True. Why?
Because both are true.
Because both are true. How many do you need for it to be true? Just one, on an or. Yeah, we're looking at an or now. All right. P is true, Q is false. P or Q is? True. Why? Because you only need one to be true. P is false, Q is true. P or Q is true, because one of them is true. P is false, Q is false. P or Q is false, because they're both false, and I need at least one to be true, and I don't have it. All right, I'm going to make it a little harder. You ready? This little squiggly line means not. Okay? And not is that inverse, right? You take the opposite truth value. So if this says not P, I'm going to come over to the P column. And this truth value is true. So its opposite is false. And so this value here is false. The next one? The next one? The last one? Beautiful. Okay, you ready for your brain to explode? You're like, please no, it's only fourth period. I have a whole other half day to go. Not P or Q. Look at the not P column. Look at the Q column. Not P is false. Q is true. Not P or Q is... I heard it. Not P is false. Q is true. Not P or Q is true, because you have at least one true statement. Yeah, it's all the P's and the Q's and the letters and things, yeah? Okay, your first statement right here, being represented by not P. Here's your first statement, dude. Right? Hey, your first statement right here. It's false. Okay? Your second statement right here, it's also false. The first statement or the second statement? What's the truth value of that? This one's false. This one's false. Am I going to get true or false? False. Because in order for an or statement to be true at the end, I need to have at least one true statement. Not P is true. Q is true. So I should have a true, because I have at least one true. Last one. Not P is true. Q is false. Not P or Q is true, because I have one true. Okay? This is where I'm going to end the video. We've got a couple minutes left in class. About one or two of you that were a little confused. Come on up. Afternoon! Goody woo, that was weird. Let's try that again. Good afternoon, 5th period. How you doing? Good. Woo! Did y'all have a good lunch? Yes. Yeah, all kind of mixed reactions there. Sorry to hear for those of you who did not enjoy your lunch. I hope that tomorrow's lunch is better. We're going to be talking about the logic of true and false, and as you can tell today, there's not going to be any drawing. It's just going to be writing, because all I have is writing utensils out. I've got 4 different colors: black, red, blue, green. Those are the ones you'll see me using. You don't have to use these colors, but you'll see me use them. All right, so yesterday we talked about conditional statements, those if-then statements, and today I want to take some time to talk about what happens when you look at a statement and you decide whether it's true or false, and you start using that to build arguments. Okay? So I want to start off with this statement. A rectangle has 4 right angles. True or false? Okay, I heard a false. Do we want to debate? No? Okay. It's all you. You know what? You probably heard me say triangle. Okay. I understand. I'm sorry. Yeah. So this one's true. It's part of the definition of a rectangle. All right. Not bad. Let's look at this next one. birds fly. True or false?
Well, no, that's like true false hat.
Yeah.
Not all birds fly. Penguins
What
can't
birds
fly,
don't fly?
ostriches can't fly.
Flamingos can't fly either, right? I know, ostriches.
They run. They run and they're fast. It's true.
I loved that this statement.
It's considered swimming.
I love that this statement, this 2-word sentence, created this class-wide debate for like a minute. It's fantastic. You're all correct. Every last one of you. It's true sometimes because hawks fly and sparrows fly and eagles fly and crows fly and ducks and chickens fly too.
No, chickens don't fly.
Chickens fly. They don't fly well.
They just go up.
They
Fly.
But they fly, yes, I had one nearly hit me in the face.
Fly and they swim.
Chickens fly.
No, but wait, are we?
They fly for like 3
I don't know if
seconds.
that's considered flying though.
Okay, when you take a piece of fried chicken and throw it at someone, that's not flying. I'm like, the bird that's still alive with feathers,
Like,
it flies, yeah.
But like
Not very well.
It's like this.
Is it, what are you sure?
Yes,
Bradley, just roosters and chickens can fly up to like a little tree.
they can't necessarily get down.
Alright, so the definition of flying, what's the
Yeah, they
definition
fall
of
down.
flying then?
They use their wings to make them go someplace.
Yeah.
Even if it's a very short place.
Oh, okay, because I thought flying considered
Was like-
being in the air for a good amount of time, like, alright.
We're going with a very loose definition. Okay. And I loved what some of you said, well, it depends, right? And then you started saying not all of them do, some of them do. Okay? And you started giving examples of birds that couldn't fly that made this statement false. Y'all said, I heard penguins,
Penguins and ostriches can't fly.
Penguins can fly.
It's swimming.
penguins, and I heard ostriches.
Yeah, ostriches don't, flamingos fly, right?
I think so.
Yes.
Yeah, you just clip their wings at the zoo so they can go.
So they can't take off and leave us.
They what?
That would make sense.
The cages are like
They
this
take
big.
off their main feathers.
And they're like-
something else so they can't fly.
I don't know.
That's pretty cool.
All right. So what you just offered over here, and I'm going to zoom this out a little bit so that you can see me right over here on the left, is very important. What you offered are called counter examples. Based on what you offered, what does the word counter example mean?
An example against the example.
An example that does what?
An example against the example.
An example against the statement. I like it. Let's use that exact definition. The counterexample is an example against the statement. It shows that that statement is false. Shows it is false. Fantastic. It's like those investigative shows, right? Like Law and Order, they're trying to prove the guy's innocent. You don't know that sound? Yeah. Yeah, the dun dun. I don't know what that sound is, but it's that sound show. Yeah, that one. And they're trying to prove that the guy's innocent, right? And there's all this evidence, and it's like, nah, dude, he's totally guilty. And then they find the one thing, right?
Yeah.
That's the counterexample. It's the one thing that makes all the rest of the stuff false. Okay? He watched it last night. He'll tell us the synopsis later. Okay, so there's the counterexample. Now, what some of you guys did in trying to find a way to make this true was you offered what were called qualifiers. Okay? And these are words that help change the truth value. So qualifiers change the truth value. And one of the ones that I heard was some birds fly was one. What was another one? Oh, it was not all birds fly, right? Not all birds fly. So some other qualifiers that you might run into, examples of qualifiers, would be, well, the sum, all, most, many, and the list goes on and on. Okay, those are just a few of the qualifiers that can change the value, the truth value of a statement. Awesome. You guys are really good at this. Take your writing utensil and put a line from one edge of your paper all the way across to the other. I'm done with that section. Do y'all know the nursery rhyme about Jack and Jill? Tell us me.
Jack and Jill went over the hill. Dang, you haven't heard that.
Oh my God.
Jack fell down, broke his cane.
Jill came tumbling out.
Right, that's the nursery rhyme. Basically, the whole premise,
Did you help Jack out?
the whole point of this little nursery rhyme is that you've got this guy named Jack and this honey named Jill, and they walk up a hill to get some water, and then they both fall down the hill. Okay?
Wow, that's a lame story.
It's a total, yeah. When you explain it,
Why they teach us that in school, dude? Like,
other than the fact that stuff rhymes, I don't know. I'm not English language arts. I don't know. But I want to look at that first sentence. Jack and Jill went up the hill. I can rewrite that into two sentences without the and. Jack went up the hill. Jill went up the hill. Okay? So I'm just going to jot that down so we don't lose track. Jack went up the hill. Jill went up the hill. All right, so we have two different statements now. Okay? And we can do that compound sentence. That's where the nursery rhyme starts, right? With that compound sentence with that word and. Yeah, so I'm going to write that back in there. Jack and Jill went up the hill. What needs to be true in order for the statement Jack and Jill went up the hill to be true?
For statement?
Yeah, for this sentence right here, Jack and Jill went up the hill. For that to be a true statement, what has to happen?
They went up the hill.
Who has to? Jack and Jill. Both or just one? Both of them.
Jack and Jill went.
Yeah, both of them have to go up the hill. You're right. Awesome. This is going to hold true. That idea that for a statement that has the word and in it, for it to be true, both parts of it have to be true.
Oh, yeah.
Okay? So that's what we're going to write here. And then we're going to write with compound and statements both parts must be true in order for the entire statement to be true. Okay, and I'm going to zoom in a little bit more so it's easier to see. All right, I'm going to change the sentence. Jack or Jill went up the hill. In order for this statement to be true, what needs to happen? Okay. Either one of them. Or both. You're right, both could go up the hill, that makes it true. Could Jack go up the hill and could Jill stay home?
Yes.
Yeah, and it's still true. What if Jack stayed home and Jill went to go do it? Still true.
It was her turn a little bit.
It was her turn, yeah.
Dang,
woman. Yeah.
I ain't going back up there, dude.
Your turn, man. You're the one who wanted to wash your hair tonight.
You're the
Yeah?
one who wants to watch.
So with compound or statements, only one part needs to be true in order for the whole statement to be true. When you're done writing it, put a big line, edge of paper to edge of paper, and give me thumbs up. Thank you, thank you. Thank you, thank you, thank you. Thank you. Thank you, thank you. Thank you, thank you, thank you, thank you. Thank you. Thank you. Thank you. Thank you. And thank you. Okay, I know that a few of you are still writing. I won't make the order go off the page. I'm going to shift it just a little bit. All right. This section, thank you. Made sure that I saw that one. You are all invited to come and eat at my truth table. I need to fix that joke. It's super lame. It's super lame. Like, not even Snickers. It was horrible. All right. So we have these statements here. Jack went up the hill, Jill went up the hill. These are two different statements. And these statements have two different possibilities. They could be true or they could be false. And we need to have a way to look at all the different possible outcomes and to be able to make sense of it and maybe talk about them. Okay? So that's what a truth table does. But I'm going to generalize it because I don't just want it to be about Jack and Jill. I want it to be about anything I want to have a conversation about. So I'm going to replace the first statement with the letter P. Okay? So now this letter P represents any statement I want to make, no matter how silly or ludicrous it sounds. The sky is green.
Whoa, whoa.
Okay?
Water's purple.
Water's purple. And that's a separate statement, so I'm going to use the letter Q. That's my Q's.
Oh, I was like, is that a flower here?
It's a Q.
Is it little Q?
It's a little Q. It's a little lowercase q. Yeah, it's weird. Okay?
Cursive.
It's a kind of cursive Q. A P and a Q.
We draw the line all the way?
Yeah, all the way. Oh, no, I didn't do it all the way, but to the next margin. It's okay if you did all the way. It kind of looks like it does. And then we want to talk first about P and Q. Okay? Now, to talk about them, if you're using different colored pens, now's the time. I'm going to use red and green. Okay? If you don't have red and green, that's okay. All right. So this statement, the sky is green, our P statement, has two possibilities. It could be true or it could be false. The second statement which you gave us, which was
Water's purple.
water is purple, also has two possibilities. It could be true or false. And so what this table does, it allows me to have all the different possible cases. Both of them are true. One's true, one's false. The other one is true and the other one is false, or they're both false. Okay, in one table. Now we're going to look at these truth values to see what the truth value of P and Q might be. Okay? So in order for an and statement to be true, what needs to happen? Both of these need to be true. So P is true, Q is true, P and Q is true. It must be true.
So the rest are false
Why?
because only one is true, and then on the last one will go false.
I couldn't have said it any better.
Excuse
Okay, all right. I couldn't have said any better, you're right. Go ahead and fill out your truth table, you're right. Go on, fill it out, you're good. P is true, Q is false. For the and statement to be true, they both have to be true. Are they both true in this case? So then it's false.
The rest of them are gonna be false then?
Yes,
Because they're not both true.
exactly.
Oh, okay. I was overthinking that.
You were. You were, and I saw it. I saw the train going. What? All right, let's look at P or Q. How many truths do you need to have in order for P or Q to be true? One or more. Okay, you only need one. As soon as you have one, it's true. P is true, Q is true. P or Q is?
True.
P is true, Q is false. P or Q is?
True.
As soon as you get that first true, you can even stop thinking. P is false, Q is true. P or Q is? P is false, Q is false. P or Q is? False. He was trying to trick us, that's what it was. He was checking to make sure that we were putting attention.
Who's he?
What's that?
Oh.
Yeah. I'm avoiding calling out names just in case anyone's like, I don't want my name said on the internet.
Oh.
Yeah. All right. This squiggly line, it's a squiggly line, this one right here, stands for not. So this says not P. Not. Do you remember when we were talking about the inverse and we said negate? What word did we add in there to negate something? Not. And we had it mean the opposite, yes? I like unicorns. I do not like unicorns. They mean the opposite. Yes?
Yes.
So then if I put here in logic terms, not P, I want the opposite of whatever this truth value is. That make sense? Don't overthink it. Just
Say
take,
that again, just add in one.
you're like, so this little symbol means
Not.
you're not. So opposite truth value. So if I gave you true, not P would be, that's
Yeah,
it.
that's right.
Yeah. All right, so fill out your not P truth column real quick. And now I'm going to try to break your heads. I really am. I'm going to try to make this too hard for you. Okay? It's because I know you're smart and you're going to get it. I wouldn't do it if I didn't think you could do it. Not P or Q. So you're going to look at the not P column and the Q column. All right? Not P is false. Q is true. Not P or Q is?
True.
Why?
Because both.
Because one of them is true. In this case, Q is true. But it doesn't matter. One was true. It's an or statement. The whole thing's true. This column here, where my fingers are, not P is false. Q is false. So the or statement is false because they're both false. Not P is true, Q is true. The or statement is?
True.
Nicely done. Not P is true, Q is false. The or statement is?
True.
True. Because you only need... Did one of you sit there, everyone said false, and someone in your mind was thinking, no, it's true, but you didn't want to say it because everyone else said false? Was that you? Yeah. You were right! All right, but I want you to look at the difference between this last statement, and this is it, and I promise we're done. This statement was read, not P or Q. This one is said, not P or Q. Do you see the difference? Do you hear the difference? Not P or Q. So you're going to look at the P or Q column and then the opposite truth values of each one. So here's the P or Q, the P or Q column. What's the opposite of this truth value? The next one? The next one? The next one?
True.
Done. Be prepped for a skill check on this sometime in the near future-ish. Afternoon, 7th period. We are recording. How are you? Woo! All right, so lights off? All right, do you mind turning off the lights there, please, please? Thank you. Awesome. All right, as you can tell, all you'll need is some writing utensils today. You'll see me switch between these 4 colors today. You don't have to have these same colors, but you're welcome to if you would like. Today is the 24th, and it is a Wednesday. You are my 7th period class.
Why did you put it in
Focus. Thank you. Today we're going to be talking about the logic of true and false. That's what I want to title the lesson today. Yesterday we talked about those conditional statements, those if-then statements. Okay? And we didn't worry about whether things were true or not. We just worried about figuring out which part was which of the if-then statement and then playing with them. Today we're going to actually talk about what happens when you have things that are true and false and you put them together in fun and interesting ways. Okay, so I want to start with this sentence. Is this sentence true or false? Texas is in the United States of America.
True.
It's true. Okay. All right, it's true because right now we're part of the United States of America. Yes. What about this statement? Athletes play football.
Yeah.
True or false?
Not all of them. Not all athletes play football.
Awesome. And I like that this sentence sparked that reaction. Where someone said, well, that's true, athletes do play football. And then some people, no, but not all of them. Okay? So right now we're going to count this one as false because there's a case that we can find in which athletes don't play football. Can you give me that counter example? Who?
Kobe Bryant.
Kobe Bryant. What does he play? Basketball. Is he an athlete?
Yes.
Awesome. So Kobe Bryant is an athlete. I hear music. If that's yours, please turn it down and off. Or off, thank you. Is an athlete who does not play football. Play football. Awesome. Now there's something important going on right in here. And that's what I had asked you to provide me when you said Kobe Bryant is an athlete who doesn't play football. And I called that the counter example. Can you give me a definition for counter example? Yeah, you're exactly right. Yeah. You go on with your bad self, you're right. It's an example that counters the thing that you're trying to say. That's a lovely definition. Let's use that. Yeah.
I didn't even hear him.
It's an example that counters the statement being made. It counters the statement being made. So if the statement that's being made is athletes play football, the counter example is the athlete who doesn't play football. It could also be, I suppose, the name of a person who's not an athlete and plays football, right? We play flag football and we're not athletes in any way, shape, or form. Right?
There's something here, too.
I also noticed what some of you guys had said about this. You guys had said, we'll wait, and this is being recorded. You guys had mentioned not all athletes play football. You changed my sentence. You changed my sentence. I'm not upset by this at all. I'm not angry in the slightest. Because this portion right here is called a qualifier. And what qualifiers do is they change the truth value of a sentence. They take the athletes play football, which was false because we weren't sure which way it was going, into a true statement, not all athletes play football. Or it makes it obviously true if we say like all athletes play football. Obviously a false statement, yeah? Because we've got that counterexample. So qualifiers can be that not all, which is what you guys used. It could be just all. It could be most, or many, or some, and the list goes on.
Miss, what does that first word say?
A little better? Okay, so you're talking about this word right here?
Okay.
All right.
Oh, that says example.
Yeah, it's the examples. I'll put a colon behind it so it makes it easier to tell. All right. So I put a big line from one edge of my paper to the other. Lovely.
Your notes.
All right. So put a big line from one edge of the paper to the other because we're going on to the next section that's related to this stuff. Have you all heard the nursery rhyme about Jack and Jill?
Went up the hill.
Yeah. What's that? How does that nursery rhyme go?
Jack and Jill went up the hill. Betcha fell water.
Uh-huh.
Jack fell down and broke his crown, and Jill came tumbling after.
That's the nursery rhyme. That's it. Good job. Fantastic. The basic idea behind this nursery rhyme is you got this guy Jack and this girl Jill, and they walk up a hill to get some water in a bucket, and then they fall down the hill. We know for sure that Jack breaks his head. We have no idea what happens with Jill. Okay? This is a morbid children's tale. I don't know why we tell it to children, but we do. But that's the whole premise of it, yeah? I want to look at just the first sentence. Jack and Jill went up the hill. And that can be written as two different sentences, can't it? Jack
Yeah.
went up the hill.
Mm-hmm.
Jill went up the hill. All right, so I'm going to jot those down just so that we can see them separate from each other.
Oh my God.
Jack went up the hill. Jill went up the hill. Okay? And our discussion is going to begin with the original nursery rhyme sentence. Jack and Jill went up the hill. If I said that sentence was true, what had to happen?
Jack and Jill had to go up the hill.
Jack and Jill had to go up the hill. Both of them?
Mm-hmm.
Or just one?
Both of them, because it says Jack and Jill.
Both of them. Jack and Jill both have to go up this hill in order for this statement to be true. And so if we generalize it, I'm going to write the word and here. If we generalize it with compound and statements, so these are statements that are being made that have the word and in there to combine more than one statement, more than one idea. With compound and statements, both parts both parts of the statement. I still hear music. If that's yours, you need to please turn it off right now. We'll wait for you. He's out of it. All right. Need you to turn that off for me, please, because it's distracting. Both parts of the statement need to be true in order for the entire statement to be true. Awesome.
Unless it looks like it's gonna read us.
Hmm.
No, I hope it doesn't.
I'm going to change. We're up here, please. Save it for later. I'm going to change the nursery rhyme a little bit. Okay? Instead of Jack and Jill going up the hill, I'm going to say Jack or Jill went up the hill.
So now only one of them went up?
So now what needs to happen in order for this sentence to be true?
Only one of them has to go up the hill.
Yeah. Only one of them has to go up the hill. Jack could go up the hill and Jill could stay home. Or Jack can go, nah, woman, you go get it. And he could stay home watching TV and he could send her out to go get the water. Okay? So with or compound statements, with compound or statements, only one part of the statement needs to be true in order for the whole statement to be true. Write a big line, straight line under that as soon as you're done. Give me a thumbs up when you have written the bar. Thank you, thank you. Thank you, thank you, thank you, thank you. Thank you. Leaning forward to make sure I see him. Thank you. Thank you. Let's take two more. Thank you. One more. Got you already. Thank you. All right, I'm going to scoot it down just a little bit. Just a little bit, not the whole thing. Just a little. All right, and now I want to invite you all to come and eat at my truth table. It's still lame. Said it all day, and I haven't figured out a way to make that joke any better. It's here. Look, I'm getting blank stares. All right. So this truth table is a way for us to look at the different situations that we could have with two statements that we're making this compound statements with, and be able to tell what kind of outcome we're going to get. But in order to use this truth table, I don't want to write out Jack went up the hill, Jill went up the hill. All right? And I want to be able to generalize it to any statement, like the sky is green. Yeah. Or squirrels have feathers. You know? I mean, it doesn't matter if these statements make any sense, whether they're true or false or not. I just want to be able to generalize into anything I'm going to say. So for that, we're going to use some letters. So I'm going to use the letter P to represent one statement. And I'm going to use the letter Q to represent some other statement. And so now I can write, instead of Jack went up the hill and Jill went up the hill, I can write P and Q, my first statement and my second statement. Now, if you've got different colors, now's the time to break them out, because I'm going to start switching colors. P has two options. Our first statement has two options. It can be either true or false. Q also can be true or false, and this table helps us get a really easy visual of all the different possibilities that we have of combinations of these two things being true or false together. Okay? They can both be true. One of them could be true, one of them could be false. We can flip that. You know, the other one can be true and the other one can be false. Or they can both be false. Yeah? All right. So now that we have our truth set up here, true and false thing, let's look at the and statement. How many truths did we need to have for the and statement to be true? One or both? Both. They both had to go up the hill for the whole statement to be true, right? So if the first statement is true, P, and the second statement is true, Q, then P and Q is a true statement or a false statement? They're both true. So the and statement is, yeah, you're right, true. Because they have to both be true in order for the and statement to be true. Does that make sense? Okay, so write in true. On the second one, P is true. The first statement is true, but Q, the second statement, is false. The whole statement, P and Q, first statement and second statement, true or false? False. Because I don't have both of them true. It's only true if they're both true. What about the next one? First one's true, second one's false. What was it? She said false. You're right. Because again, we need to have both statements true. What about the last one? They're both false. But what did we have to have in order for the whole thing to be true? Yeah. The last one is also false because neither one is true. And in order for an and statement to be true, they both have to be true. Okay? Ooh, my line is messy. All right, let's look at this one. P or Q. How many truths do you have to have in order for the or statement to be true? How many do you have to have? I'm getting a one finger for the or statement. Just one of them. If the statement Jack or Jill goes up the hill is true, how many of them have to go up the hill for that to be true? Just one. Both of them could go up the hill and we're okay with an or statement. But as long as one of them goes up the hill, we're happy. So as soon as we get a true statement, the whole thing's true. Okay? P is true, Q is true. P or Q is true. Because I have at least one true. P is true, Q is false. It's still true because I have one true in there. P is true. I'm sorry, P is false, Q is true. P or Q is true because I still have one true. Doesn't matter who is true, just as long as we have one. P is false, Q is false. It's false because I don't have a single one in there. All right, you guys are really good at this. All right, I just have a little bit more on this truth table and then we are all done. This little squiggly line right here. Yeah, the swoop, the tilde that makes the N the enye. Here in geometry for us it means not. And when we did inverse, what did we use that word not to mean? When we negated the statement on the inverse, we use the word not. Yeah, the opposite. Yeah, so take the truth value that's there and give me the opposite. False here on the first one. Second one? False. The third one?
True.
Beautiful. The fourth one?
True.
Lovely. All right, I'm going to make it look really weird for you guys, but I know you guys are super smart. You can get this. You ready? Ready? Not P and Q. Okay? So you're going to look at the not P column, and you're going to look at the Q column. This is an and statement, so how many truths do you have to have for it to be true?
One.
This is an and statement.
Oh, two.
2. All right, so the first one, not P is false,
True.
Q is true. So your and statement is,
True.
how many truths do you need to have?
True.
2. Do I have two truths here?
No, it's false.
There you go. I don't have 2 truths. It's false. The next set,
Oh,
I have 2 falses. So it's false because how many truths do I need?
two.
How many do I have?
None.
So it's false. There you go. Next one, how many truths do I have?
Two.
So the answer is lovely. And the very last one, how many truths do I have? 1. And so it's, there you go. That's about as tricky as I think I could make this. That's it. That's all there is to this.